We are doing grade 11 chemistry NCERT exercise for the chapter Some Basic Concepts of Chemistry, and today we'll do question 1.13 to 1.18 in this video. And for question 1.1 to 1.12 you can refer my previous videos for the same chapter. So first question, question 1.13. It is given pressure is determined as force per unit area of the surface. The SI unit of pressure Pascal is shown below. 1 Pascal is equal to 1 Newton per meter square. If mass of the air at sea level is 1034 grams per centimeter square, calculate the pressure in Pascal. So in the given question, we need to calculate the pressure in Pascal, and the information which is given to you is this is the only information. Okay. Now here, what is the meaning of 1034 grams per centimeter square? That means this very mass of air is given to you and it is acting on a surface which is 1 centimeter square. So two informations are there. Mass is given and the area is also given on which this mass is putting pressure. So we need to calculate pressure. Pressure is force per unit area, but in this case, force is basically the gravitational force, that is the weight of the air. And gravitational force or the weight is calculated as mass into acceleration due to gravity. So we can say that pressure is basically weight per unit area in this case. So pressure is equal to mass multiplied by acceleration due to gravity divided by the area on which this mass is acting. Therefore, this information, mass, is given to you in the question, and acceleration due to gravity is having value 9.8 into 10 raised to the 9.8 meters per second square, and area is also mentioned in the question, that is 1 centimeter square. Okay, now here your acceleration due to gravity we have taken in standard system, that is SI system of unit, but mass is in gram, that is not standard system, as well as the area also, it is in centimeter square. So we'll convert the unit according to this scale, according to the standard system. Therefore, mass will be converted into kilograms by this relation, and your centimeter square will be converted to meter square with the help of this scale. So we will put down the values, and this is what mass in kilogram, and this is the area in meter square. So we will simplify the values and we will get this value. And here we are getting unit as kilogram meter per second square. It is nothing but Newton. So 1 Newton is what? Mass acting mass with acceleration due to gravity in meters per second square. So we will get value 1.01332 into 10 raised to the power 5 Newton per meter square, which is equal to Pascal. So this is your answer. Now come to the next question, 1.14. What is the SI unit of mass and how it is defined? SI unit of mass, all of us know it is kilogram, and it is represented by kg, that is capital K small g, and the kilogram is defined as the mass of platinum iridium cylinder that is stored in an airtight jar at International Bureau of Weight and Measurement in France. And basically this is the prototype of the mass. Therefore, the 1 kilogram is defined as the mass of international prototype of kilogram. Okay, so this is 1 kilogram. Next question, match the following prefixes with their multiple. So micro means 1 divided by, we are putting 6 zeros. Okay, that is 10 raised to the power 6. So this is for micro. The first one will be this one. Micro will be 10 raised to the power minus 6. So it will be this one. Okay, next, deca. Deca is 10 raised to the power 1 or simply 10. So therefore for deca we will match here. And third one is mega. Mega is a bigger unit. It is 10 raised to the power 6. Okay, so therefore for mega we will go here, the first value, that is 10 raised to the power 6. And for giga, we are having, again, giga is a bigger unit. It is 10 raised to the power 9. So this is giga, 10 raised to the power 9. And last is femto. Femto is the smallest unit among all units which are mentioned here. It is 10 raised to the power minus 15. So this is the femto. Next question, 1.16. What do you mean by significant figures? Okay, so to have an idea what is significant figures, we need to understand that when we do any measurement with instrument, we are supposed to have some errors, and most of the time the value that we will find out, it may or may not be the accurate one. Okay, and if the same measurement is done by different individual, we will get different type of values. So therefore the value which we used to mention is having some uncertainty. Okay, so on the basis of this idea, we define significant figures. So the total number of digits in a number, including the last digit whose value is uncertain, is called as significant figures. So therefore, significant figure include all digits which are certain or which we know accurately, plus one more digit for which the value is uncertain. So let us take an example. For example, mass of an object is determined as 14.5678 grams, and the instrument that we are using for this measurement is having accuracy of this level, that is 0.0001 gram. That is, there is an uncertainty of 1 unit at the 4th digit after the decimal. So therefore, what we understand by this, that the values may be written differently by different individual, or if the same measurement is done at different time. So it may be in between 14.5677 and 14.5679. That is, we are having uncertainty of plus minus 1 unit at the 4th place of the decimal. Okay, so therefore we define here the number of significant figures as the certain digit, the digit for which value we know with certainty or with accuracy, that is 14567, 5 digit, plus one more digit for which the value is uncertain or dicey, or which is having uncertainty of plus minus 1. So this is 5 plus 1, therefore we are having 6 significant figures. Next question. A sample of drinking water was found to be severely contaminated with chloroform, supposed to be carcinogenic in nature, and the level of contamination was 15 ppm by mass. So we have to find out mass percent and molality of chloroform in the given water sample. So in this question, first focus on what is given to you. They have given you a water sample or a drinking water sample, and this water sample is having one contaminant as chloroform, which is highly dangerous for us. Why? Because it is carcinogenic. So here concentration of this compound is given as 15 ppm. What is the meaning of ppm? ppm is parts per million. Okay, that means 1 ppm means, what is the meaning of 1 ppm? That is 1 part in millionth part of the given solution. So here ppm is by mass. It means 15 gram of chloroform is present in 10 raised to the power 6 grams of water or the given sample. Okay, first we have to find out the mass percent, for which we need mass of the solute divided by total mass of the solution multiplied by 100. So mass percent of chloroform is calculated as mass of solute, as from ppm we have taken it as 15 gram, and mass of solution will be 10 raised to the power 6 gram multiplied by 100. So here gram will cancel out, therefore I'm not writing it here, and the mass percent will be 1.5 into 10 raised to the power minus 3%. Okay, so it means what? It means in 100 gram of the given sample of water, we are having this very amount of chloroform. Okay, now second part is we have to find out the molality, and molality is number of moles of solute divided by mass of solvent in kilograms. So for this we need these two information, and for number of moles we need molar mass. So the molar mass of chloroform is calculated, as I told you before. Whenever we are having any numerical related to the concentration, we need to find out number of moles in most of the cases. So molar mass of the chloroform is calculated as a sum of atomic masses of all the atoms which are there in the molecule. That is 12 for carbon, 1 for hydrogen, 1 atom. But chlorine, we are having 3 atoms, therefore 35.5 into 3 will get molar mass of chloroform as 118.5 grams per mole. Okay, why we are writing grams per mole? Because this is the mass for 1 mole of the substance. Now, next is we will calculate the number of moles. So, mass we have calculated here. Therefore, this mass divided by the molar mass, you will get number of moles. So, we'll simplify this later on. Now, the second information that we need for molality is mass of solvent. Now, mass of solvent is not given to you. They have given you mass of solution. So, here we will do one approximation. Mass of solvent is taken approximately equal to the mass of solution, which is 100 gram or 0.1 kilogram, as we have taken here. Why? Because we have taken a very dilute solution. Okay, and in a dilute solution, mass of solvent is approximately equal to the mass of the solution. Okay, so molality of chloroform is calculated as number of moles of chloroform that we have calculated here divided by mass of solvent, this one. Therefore, we'll get value 1.266 into 10 raised to the power minus 4 moles per kilogram. Or we can write the same value as small m, that stands for molal. Okay, so this is your answer. Next question. Express the following in scientific notation. Now, first understand how to write down the scientific notation. When we are writing any number in scientific notation, we write down the first part as capital N, where it is the single non-zero digit. Single non-zero digit to the left of the decimal point. What is the meaning of single non-zero digit? That means n should be less than 10 or it should be greater than 1. Okay, so rest of depending upon the value, we will get some power of 10, and this n stands for the exponent. It is an integer. It may be positive or the negative value, or even it may be 0. Now for the first one is 0.0048. Now we need to have value less than 10 or greater than 1. So what we will do, we will shift this decimal to this place after 4. So we are shifting decimal 3 places, 1, 2, 3, and that too to the right. When we are shifting decimal to the right, we will put 10 raised to the power, negative power of the 10. So it is minus 3. Why? Because we are shifting 3 places to the right side of the decimal. Okay, and the value will be 4.8. So this is the value 4.8 into 10 raised to the power minus 3. Now the next one. In this we are not having decimal. It means decimal is in the end. And we need to shift this decimal after 2. That is, we are shifting how many places? 1, 2, 3, 4, 5 places to the left. When we are shifting to the left, we will put positive power of 10. That is, your n is 5. In the previous case, n was minus 3. Okay, so here it will be 2.3400 into 10 raised to the power 5. Now, next one. In the next one, we are not again having decimal. So, a decimal is in the end. We will be shifting to the left 3 places. Therefore, 10 raised to the power 3, and here is 3. Why plus 3? Because we are shifting to the left. Okay. And value will be 8.008 into 10 raised to the power 3. Next one is 500.0. Here we will be shifting decimal again to the left, but here we will be shifting 2 places. So therefore n here is plus 2 and the value will be 5.000. Now the next one, 6.0012. So the value is already in the required range. Therefore, we will put 10 raised to the power 0. Okay, and here is equal to 0. So this is all about scientific notation. I hope this is clear.
Thanks for watching our video. Don't forget to like and subscribe as we will be posting more videos on this topic soon.